Hi, it's Jo Karen Hudson. Today I'm going to talk with you about evaluating polynomial functions. Example 1. Let's start off with the function 5x squared minus 2x plus 7. The first thing we know we need to do is to wrap the variable in parentheses. The variable is x, so we're going to wrap it in parentheses, and I'm going to start off by doing p of 2. P of 2, if I replace the x with a 2, I'll have 5 times 2 squared minus 2 times 2 plus 7. And now I can pop it in the calculator. Be sure when you pop it in the calculator you type it exactly how it is. 5 times 2 squared minus 2 times 2 plus 7. And that gives me 23. So this first example turns out to be 23. Alright, let's do the second example. P of negative 3. So I'm going to be replacing the parenthesis with a negative 3, replacing the variable with the negative 3. So I'll have 5 times negative 3 squared minus 2 times negative 3 plus 7. So I'll put this in the calculator. 5 times negative 3 squared minus 2 parenthesis negative 3 plus 7. And this one will give me 58. And the last one, P of 0, would be 5 times 0 squared minus 2 times 0 plus 7. This would give me 0 minus 0 plus 7. The third solution is 7. Example 2. A firm determines that the total cost in dollars of producing X pair of sunglasses is given by this function. C of x is equal to 5,000 plus 0.4x squared. What is the cost of producing 50 pair of sunglasses? So I'm going to be doing C of 50. Now my original function is 5,000 plus 0.4x squared. I'm going to wrap my variable in parentheses so that I'll have 5,000 plus 0.4, replacing x with 50 pair of sunglasses, squared. Pop it in the calculator. 5,000 plus 0.4, replacing the x with 50 and squaring it, would give me 6,000. So the cost of producing 50 pair of sunglasses would be $6,000. Collecting like terms in a polynomial. In order to collect like terms, we need to combine the terms by adding or subtracting the coefficients and keeping the variable part the same, keeping the like terms. Write the terms in descending order with the highest exponent first. Example 1. The highest exponents are x squared. This is like 1x squared plus 2x squared, which would be 3x squared. And then we have negative 5x plus 6x. Negative 5 plus 6, if you put that in the calculator, would be 1. So we're just going to have plus 1x or just plus x. Example 2. We want to combine like terms, and we want to leave them in descending order with the highest exponent first. So we'll start off. There's only one x cubed term, so we'll have 3x cubed. There are 2x squared terms. This is like negative 1x squared minus 5x squared. If we combine negative 1 and negative 5, you put negative 1 minus 5 in the calculator, you'll have minus 6x squared. So there's the x squared term, and then the constant terms are 4 plus 2, which is 6. So our final answer. And the last example on this part, we want to combine the like terms, starting off with the y to the fourth. That's the highest exponent. We have 2y to the fourth minus 3y to the fourth. So we're combining the coefficients 2 minus 3. You can put that in the calculator. It'll give you negative 1. You can either put negative 1y to the fourth, or you could just put negative y to the fourth. We only have one y squared term, so we'll just have negative y squared. And then we'll need to add 1/2 plus 1/3. And if you need to do that in the calculator, you'll do 1 divided by 2 for 1/2 plus 1 divided by 3 for 1/3. It'll turn out to be a decimal. Math, enter, we'll put it back to a fraction. So that will turn out to be plus 5/6 plus 5/6. Adding and subtracting polynomials. Adding, subtracting, and multiplying polynomials. First of all, adding and subtracting. We will eliminate parentheses, combine the like terms, write the terms in descending order. Okay, when we add or subtract polynomials, we'll first take off the parentheses. There's nothing out in the front of either one of these, so we can just take the parenthesis off. 3x squared minus 6x plus 8. This would be plus x squared plus 3x plus 10. What I'm saying is there's no number to distribute out in the front. It's like distributing a 1, which gives you just exactly what you had. So let's add the like terms together. First of all, we have the x squared terms. There's 2x squared terms. So we'll be adding 3x squared and 1x squared, which would give us 4x squared. And then we have the x terms. There's negative 6x plus 3x, and negative 6 plus 3, if you put that in the calculator, turns out to be negative 3x. And then we will actually combine the constant terms. Positive 8 and positive 10, and 8 plus 10 is 18. So we have plus 18. Our second example. On the first group, we can take the parentheses off. There's nothing to distribute. But on this second part, we need to distribute negative 1, which means we get negative 1 times x squared, which is negative x squared, negative 1 times 3x, which is negative 3x, and negative 1 times positive 10 is negative 10. And then we'll combine the like terms. So we have 3x squared minus 1x squared, which would be 2x squared. We have negative 6x and negative 3x. Negative 6 minus 3 would be negative 9x. And then we have our 8 right here minus 10. And 8 minus 10, if you put that in the calculator, is negative 2. Okay, this is our last example on this section. We'll take off a parenthesis. There's nothing to distribute out in the front, so we'll have negative 4x cubed plus 9x. Here we're distributing a negative 1 times the x squared plus 10, which gives us negative 1 times x squared is negative x squared. Negative 1 times 10 is negative 10. And then we can just take the parenthesis off here because there's nothing to distribute. We want to combine the like terms, keeping them in descending powers. The highest exponent is the cubes. So we'll have negative 4x cubed and negative 5x cubed. Negative 4 minus 5, if you're putting it in the calculator, would be negative 9x cubed. And then we only have one squared term, so we just bring down the negative x squared. And then we have 9x plus x, and that's plus 1x. 9 plus 1 would be 10x. And then we only have one number left, and that's minus 10. So there we go. This is Jo Karen Hudson. Thank you, and have a wonderful day.